All right, so today what I'm going to talk about is basically the methodology of corpus linguistics, theory of corpus, and practice of doing corpus research, and corpus building as well. So first, let's start by going over the main topics. So what I'm going to be talking about today is the methodology of making corpus and doing corpus-based research. Then I'm going to try and cover theoretical basis of corpus really briefly. And finally, I'm going to talk about some practical problems as well. So these are three main topics, but I might occasionally stray away into one of them more than the other. But in general, this is what we're going to do today. So first question, why do we actually need to bother with this at all? Why do we need corpus studies? The first reason why we should bother with this is to actually examine the language patterns and track how the language changes over time. The language, as you all know, I'm pretty sure, is a fairly dynamic environment and it changes, well, I won't say it changes really fast, but it does change at a significant rate. So how do we track those changes? One of the ways to do so is by using corpus studies to track the language patterns and changes over time. Second, corpus studies actually helps make the language more accessible digitally. Any online translators, voice recognition software, speech-to-text, text-to-speech, etc., is in one form or another driven by the corpus studies, because it is by using the corpus that the machine can actually learn what language is and it can actually learn how to use it. And finally, we can enable more technologies to function in more languages. This actually ties up to the previous point, but the modern technology also depends on corpus studies a lot to make sure that it can function in more than one language. For example, voice assistant on Apple devices, Siri, for now, for example, it cannot really function on many of the devices in more than like English, Russian, and other languages. For example, Kazakh is not included in Siri by default because, well, it just doesn't have the resources to work. So corpus linguistic studies can actually fix this. Now, let's talk about how you actually work with corpus. To work with the ready corpus, for example, the British corpus or Russian corpus, you need to know a few things to actually do it. First, you need to know what you're looking for. You need to know what you're looking for because the corpus itself is fairly large. There are millions of words, and you can easily get lost if you're just looking for something, nothing in particular, but just looking around, so to say. So you need to know exactly, or more or less exactly, what you're looking for. Second, you need to know where to actually look for it. What kind of sources do you need? Do you need more formal, maybe more informal, news format or literary format? You should know what is the scope, where that word is and what you're looking for. Next, determine the language. The language in this context actually refers to two things. First is the actual language, like English or Russian or Kazakh or any other. And the second thing, which actually ties up to the previous point, is that you need to know what kind of language you're looking for. Formal, informal, regional dialects, and others. So you need to know exactly where you're looking for it. Next, you're going to have to determine the scope and the sources. So what that means, you need to determine what kind of corpus will source your data, what kind of text it's going to use, and how broad are you going to look at the text. That is the basic research methodology for it. And finally, you need to find the corpus. And sometimes you also might need to find the tools. Now, there are many corpora that actually come with their own inbuilt tools. For example, the Kazakh language corpus, which is based in Almaty, actually does have its own tools to work with on the website, but the quality of the tools, etc., is not always that great. The American and the British corpora, they also have their own tools, and you can work with those corpora using those tools. However, that is not always the case, and sometimes you're just getting raw data, and you would have to work around that. But I'm going to talk about that a little bit later. So, as we've already talked about in the previous lectures, when working with corpus, there are actually two ways to do it. First is a corpus-driven research, and second is the corpus-based research. So what corpus-driven research does is it essentially takes the corpus as the main source of hypothesis and the source of data. This enables the researchers to uncover something that was previously unknown about the language. It helps if you approach the data that you have with actually minimal assumptions. That is, you're not looking for something in particular, like very particular. Instead, you have a general idea of what you would like to discover, and then you're looking around the corpus, and as you go, you're building your hypothesis, you're building your theories. That is how it works. And the corpus-driven research is pretty good for the languages that have been understudied, basically, and for broad research. Now, what I mean by understudied is a language that hasn't really enjoyed the attention in the digital sphere a whole lot. For example, it would work with the Kazakh language, it would work with probably Russian language, but corpus-driven research, if you're doing it in English language, it would really have to be on a very specific topic, because English language has been fairly well studied over the years. Which moves us to the second type of corpus research. It is corpus-based research. So you're using corpus in this case just as a data source. You're approaching the corpus with a particular set of theories, assumption, and hypothesis. And what you're essentially trying to do is you're trying to confirm or deny the hypothesis using the corpus data. This kind of corpus is actually very good for some specialized and narrow topics, but not so much for the broad research. And here are the examples of the types of research. So for corpus-driven research, for example, we could consider the Kazakh poets' views on political changes in 20th century. Now, there is hardly corpus of 20th century Kazakh poets, or maybe there is one, I'm not entirely sure what happens with the Almaty corpus. But this is the general idea of what you can actually do with the corpus-driven research. You can definitely consider the Kazakh poets of the 20th century and see how they actually react to political changes, what kind of words, what kind of constructions they use, what kind of topics they're considering. That is all going to be the corpus-driven research. You're approaching the corpus about Kazakh poets with as minimal assumptions as you can, and then you go from what you discover. On the other hand, we have the corpus-based research. And one of the possible topics could be the possessive suffix atrophy across Kazakh newspapers over 2000 to 2010. Now, I also have no particular idea if there is a good representative corpus of Kazakh newspapers over 2000 to 2010. I assume there is one, probably. It's probably part of the Almaty corpus, but anyway. So what this corpus research does is it approaches the corpus with a particular assumption that there is an atrophy of one form or another of possessive suffix, and that this atrophy is actually well represented in Kazakh newspapers over this given period of time. Now, it might be true, also it might be false, and this is what the research is going to find out. But what you need to notice about it is that there is a particular assumption, and the corpus is unlikely to change or somehow add another assumption to it. There is an assumption that there is a change in possessive suffix, and the assumption is that it is getting atrophy. So we're going to confirm or deny that. All right, now let's move on to actually the theoretical basis of corpus. So as we've already mentioned before a few times, corpus is a collection of natural text that can be processed and used by a machine. And what I mean by the word processed is not that it can be understood, but that the machine can actually work with it. You need to make the text understandable for the machines in the sense that they can actually work with the text. It can break it down, it can reassemble it into something else different, but you don't necessarily have to give proper full semantic understanding of the text of the machine. Because frankly speaking, they somewhat could do that on a semantic level. However, it takes another corpus, and it also takes something like machine learning and artificial intelligence. Smarter systems definitely can understand the text, using the existing data. For example, a system like voice recognition or speech-to-text software. They definitely can understand the spoken or written text using the existing data. However, they do rely that there is something that already exists. So what happens if the existing data is not sufficient? Well, if there is not enough data, what you need to do is actually make the data. Sounds easy, but in reality, it's a little bit harder than that. But anyway, let's move to the tools. There are actually a few tools available for the corpus building and corpus management. And they have been mentioned in the readings for this week as well. So if you would like to find out more about them, you can actually go onto their respective websites and see there. I'm not going to talk about them in detail here because it's just going to take way too much time. So what you need to know though, is that all those tools are not always mutually compatible. They can have different annotation systems, different parsing approaches. They can have, well, pretty much different everything as far as differences go. So they're not always mutually compatible, and you need to take that into account when working with different corpora or using different tools. However, if there is no tool for that particular language or that particular corpus, the simple answer is to, well, create one yourself. And how to actually do it, I'm going to talk about in just a moment. So why is it important to make machines understand and how you actually make the machines understand? As I've already mentioned before a few times, humans can use semantics and they can also use pragmatics to process the text. Excuse me. However, machines must actually be told what is what, that this particular array of characters is a noun and this particular array of characters is, for example, a possessive suffix. They actually need to be told that because they don't really know. So annotating and parsing the text actually enable the text processing. In a sense, parsing and annotation are actually already the ways of text processing, but in general, those two are the ways in which we can make machines understand what is actually going on with the text. So what is parsing? Parsing is the process of actually reading the text by a machine. You can go either character by character, you can go word by word, you can go sentence by sentence. Well, it all really depends on what you're trying to accomplish. The parsing stage is actually a preparatory stage for the annotation. You need to first break the text down into its pieces, into words. Well, preferably words for the most part, and then you can work with it in more detailed ways. There is no one particular way to actually do parsing because it all depends on the research. It all depends on your data as well. If you're having audio data, if you're having text data, if you're having text data, and if you're having all kinds of data, parsing is going to be different. And one of the methods is actually morphological parsing. Morphological parsing, as you probably might guess from the word morphological, refers to the method of finding out what a given word is built from, what kind of prefixes, suffixes, or infixes it has, and what is the lexical root. So this method of parsing is actually what most corpuses would probably use to break down the words, to break down the natural text, because it helps find out the lexemes that are used in the language most often. Of course, this is not the only way, as I mentioned before, there are many others, but this is the one that will probably be most useful for working with the corpus. So this is an example of parsing that I'm actually using within my own master project. So at the top, we're having a sentence in Kazakh language. And then I'm running it through a program. This is only preliminary parsing because as you can see, it doesn't really detect much except for the letters. So if we are going through this symbol by symbol, the letter S actually stands for the space because I need to differentiate between the space and the letters. And all the actual letters are encoded as numbers. So capital letters have different numbers when compared to the smaller ones. So the logical question here would be, why not just store this as regular letters? Why do you need to actually do it as a numbers system? And the answer to this is fairly simple. It just takes less storage. This brings me to the topic of actually storing the data. Here is why I'm using numbers for my own project. So in this picture, going from left to right, you can see that Kazakh symbols take 80 bytes, numbers take 40 bytes, and Russian symbols take 80 bytes. So what that essentially means is that if I'm going to store all the articles in Kazakh language using the Kazakh symbols, it's going to take twice as much space as when I'm using the numbers. So this is actually one of the more practical considerations for a corpus building. That is, if you're building a corpus, you really need to think where you're going to store the data and how you're going to store the data. Now, of course, for some languages like English, for example, it doesn't take 2 bytes per one symbol. It actually only takes 1. So for the one English symbol is also going to take 40 bytes. Of course, one could then say, well, why don't you use the Latin characters for Kazakh language? And that is actually a fairly valid concern. However, when using the Latin alphabet, I'm sure you're aware of what kind of mess the current Latin alphabets are. So this would either call for creation of a new system specifically for this corpus or for adoption of one of the existing ones. Actually, in my current project, I'm also trying to work with the Latin alphabet, and so far it's proving to be a mess, really a lot worse than the Cyrillic. And here's quickly why. Because the Kazakh language has those specific letters that I'm sure you know about, like a, k, r, and all those need to be somehow encoded in Latin characters. And there are actually some letters that use 3 characters instead of 1. So that makes it more complicated. So that is why I'm preferring to use the numbers, because it makes storing and processing all that easier. Now, let's talk about annotation. You can have 2 ways of annotating, and they're both good in their own right, but one has advantages over the other, I would say it like that. First is the regular manual annotation. So manual annotation is pretty good for small scale projects, like student projects, for example. It works well there if you don't have like 1,000 words to annotate or 10,000. Annotation is done by the researchers. As I mentioned, it's manual, but it is not feasible for large projects. For example, even if you annotate like, say, a word a second, it's going to take you a minute to annotate 60 words. And then if we're going mathematically, it is going to take you a long time to actually annotate the data that you need for a representative corpus. And what I mean by representative corpus is a corpus of like at least 1 million words. It's going to take you a long time to annotate all by hand. And by the time you're done, I don't think you'll want to do anything with the corpus ever again in your life. Now let's move to a more, I'd like to avoid the word superior, but I really cannot. So more superior way of annotating, it is automated annotation. The pros of automated annotation is that it works across all scales. You can use it on a smaller project, you can use it on a bigger project, you can use it on absolutely gigantic project. It's going to work. Annotation in this case is done by machines following some specific rules. And this rules, actually known as rule-based annotation, have to be set by you, the researcher. And this is actually one of the drawbacks of this method, is that setting the rules might be very time consuming because you have to be very meticulous and careful to actually cover everything that you need to cover. For manual annotation, for example, this is not really an issue because all the rules are in your head. All the rules for the language, how it works, are already in your head and you know how to work with the language. So you don't have to set any rules for anyone but yourself. However, the machine doesn't really have the luxury of having the same rules in its central processor, I guess, for this case. So you have to set the rules in the program and the program will then follow all those rules to actually annotate. And if you're making a mistake, well, then the entire dataset is going to have to contain that mistake and you're going to have to fix it later on. So for the annotation system, there is no particular standard way of annotating. That is, there is no convention on what actually to say for a particular part of speech or for a particular suffix or prefix. There are, of course, the best practices on how you can actually do it. However, it ultimately depends on what you're trying to accomplish with your corpus and what you're trying to get, what kind of data. Annotation can definitely be different depending on the research focus. For example, if you're trying to do just standard corpus building by morphologically breaking down words, you're going to want to annotate what is noun, what is suffix, what is prefix, if it exists in that language, what is interfix, etc. If you're more focusing on the discourse analysis, what you might be interested in is also the intonation. You might be interested in the gaze, you might be interested in the gestures, etc. And while it's definitely going to be more time consuming and more of a manual labor to actually do this kind of annotation with the gazes and intonation, of course, you can train an AI system to do it for you, but then you have to train it. So depending on the research focus, you might want to approach the annotation in lots of different ways. Generally, standard generalized markup language, SGML, is actually a good way to approach annotation. And one of the more well-known examples of that language is the HTML, hypertext markup language. So why is SGML particularly good for this? Because SGML employs a system of tags, so to say. The tags are the things that are enclosed in those angle brackets, I think they're called, in those angle brackets. And the angle brackets actually contain all the information and all the metadata about the text. So in this context, metadata refers actually to the context about the text. What is the text about in general? Where was it encountered, etc. So SGML allows us to basically include all kinds of information about the text within the document and have it organized and stored fairly neatly. Of course, it depends also on you, what kind of approach are you going to take. But generally, SGML can work very well to actually make sure your corpus is well annotated throughoutly and that it has all the data you need to work comfortably with it. So there are also special notes regarding the parsing and annotation, and I'm sorry for the small font here, but well, I'm going to read it out anyway. So if you've taken the language typology class, you already probably know that there are several types of languages, but for this particular case, I'm going to focus on the analytic and synthetic languages. So analytic language is a language where the word to morpheme ratio is nearly 1-to-1. So what that basically means is that there is very little of attachment between a morpheme and a word. They're mostly function as separate words. I think Vietnamese language is a decent example of the analytic language. And this kind of language can actually be read regularly from start to end. That is, you can read from left to right or right to left, depending on how the language usually goes. And you are not going to miss anything in the word, and you are going to parse and annotate it correctly. On the other hand, we have a more difficult case of synthetic language. Synthetic language is the language that actually attaches morphemes to the roots of the word, and it actually changes them. Of course, there are many types of synthetic language. It can be agglutinative, it can be fusional, it can be other types, but what actually matters is if the morphemes are attached to the root in the synthetic language, it's going to require some special parsing and annotating strategies. So what you would like to do in this case is you would like to develop a special strategy to actually catch all the morphemes. And yes, Dr. Filchka noted already in the chat. So for example, Kazakh language in my project is best read from the end to start. And why is that? Kazakh language has mostly suffixes that are used in it. So if I'm reading it from the start to end, I'm going to run first into the root, and then I'm going to run into the suffixes, and I will have no good way of differentiating which is which. So I would have to, I don't know, probably guess or do a random search, which is not the best strategy, as you can already imagine. So what I'm going to try and do is I'm going to go from the end to start of the word and actually look up the morphemes using this kind of reverse reading technology. So what I'm going to do is I'm going to take one symbol, compare it to all the possible suffixes. If it doesn't exist, then I'm going to take two symbols from the end, compare it again to all the existing suffixes, and I will go in this way until I actually find out that it is a morpheme, in which case I'm going to mark it as such, or that it is a root. If it exceeds, for example, 4 symbols, I think, for Kazakh language is the most, then I'm going to make a call that, yep, this is a root and we're done here. However, this kind of strategy would actually not work that well with the Russian language, which has prefixes as well. So if we take a regular Russian word перестановка, for example, it has the prefixes and it has the suffixes. So if I'm going to read it just from the front, I will catch the prefix, but I might miss out on the suffix. If I read it from the end, I might miss out on the prefix. So in this case, well, what you could do potentially is read it both from the start and from the end, so that you actually parse everything that there is to parse. Of course, there are other approaches to that, which includes looking up the lexical root and then marking everything else as a morpheme. But that is the case for more advanced corpus, and I don't think we really need to cover it in the scope of this presentation. But there are definitely ways to parse this kind of language. It just really depends on the researcher and what you're trying to accomplish. So once all is said and done, once you've parsed it, once you've annotated, once you've made a database and everything else, what you need to consider is a search system. So the final step of any corpus basically is making a way to navigate it and search across it. Because what good is the corpus if you cannot really search for the data in it? Search engine should be mostly customized to your method of annotating and parsing. And why is that? As I mentioned before, when somebody is going to look at your corpus, they might not always intuitively know what you mean by a particular annotating tag or what you mean by a particular parsing system. Because if somebody looks at, for example, my parsing method, which I've already shown you a few slides before, they might not really intuitively realize what all those 1s, 14s, s's, etc. mean. So you need to make a search engine to actually make sure the users are comfortable using your corpus and that they can actually work with it. So what the final product gets us is basically a working corpus that can be used for various research purposes. Of course, the definition of working corpus in this case is kind of vague. So what I mean by working corpus is the corpus that has been annotated, that has been parsed, that has all the relevant metadata, and that is actually accessible to the public. Of course, you can just make the search engine accessible and hide the corpus, but in this case, the usability of your final product greatly decreases. Because if you also provide the people with the initial source data, they can actually use that corpus to annotate it themselves and use it for their own research practices. Perhaps when trying to do the morphological parsing, it did not account for machine learning research that is going to use a very different annotation. Or when doing machine learning kind of annotation, you did not account for the discourse analysis or for learner corpus type of approach. So those all actually contribute to the usability of the corpus. So a working corpus would have the source data, it would have the annotation, it would have the parsing, it would have the metadata tags, and it would have the search engine to actually search across it. The second note here is that there is no such thing as too many words for a corpus. The more representative corpus is, the better it actually is. Because if you have, say, a corpus of, well, 1,000 words, it's not going to be particularly representative, is it? It's not going to include many words of the language, and it's just going to give a fairly poor impression of what the language actually is. If we up the scale to like 10,000, it's already a little bit better, but still not as good as, for example, 100,000. On the levels of hundreds of thousands, like for example, 800,000 or 1 million, well, we can actually talk about the representativeness of the corpus. So what that means is that it contains actually enough words to have a sturdy research base under it, and that we can actually use it to define the language, and that we can actually draw some conclusions based on it. So that is ideally what the working corpus should be like. So next up is a slide that I've called corpus for the sake of better corpus. So the first corpus that you make, for example, can actually be used later to train the artificial intelligence to recognize the words, parse them, and annotate the text without human participation. Now, what that basically entails is that you take the first corpus that you prepared and you annotate it in such a way that it is useful for the machine learning data. Now, I'm not going to go into the details of how machine learning and AI actually works, because it goes way outside the scope of this class. But generally, what you need to know is that essentially machine learning is just a way of pattern recognition and classification. So what that means is that first it needs the set of training data on what a particular thing is, what a noun looks like, what a verb looks like, what a verbal suffix looks like, what a dash looks like, what a dot looks like, etc., etc. So as it goes through the data, it learns to identify the pattern recognition technology in this case. So as it goes through more and more words, as I've noted down before, the larger the initial training data set, the higher the accuracy. As it goes through the training data set, it actually gathers the information on how this particular data set functions. And the more information it gets, the more accurate its classification is going to be. So then, when faced with the actual texts, the AI is going to apply what it has learned from the training data and actually parse it and annotate it itself. Of course, there is always margin for error. In machine learning in general, it is considered to be, well, okay if you have around 80 to 90% accuracy. Of course, the more the better, but generally 80 to 90% is already pretty solid, I would say. So you can actually improve your corpus and your future corpora by taking the first one that you've done and then feeding it to the machine learning model. Of course, you cannot just get any machine learning model. You'd have to make a specific one for the corpus. And if some of you are considering this kind of endeavor, please use Python. It's one of the best ways. Don't try to use Java or C or anything like that. Just use Python. It's one of the best programming languages out there for this kind of purpose, for the AI. So now we've moved to our final slide, which is the final thoughts. And this actually happens to be the small mini assignment that is going to count for extra credit in the feedback form. So given what I've talked about, how would you process audio data? As you might imagine, the difference between audio data and the text data is that audio is, well, really the text can be represented by characters, audio, well, cannot be represented by characters. It is audio, so it has waveforms, etc., and frequencies. So think about how would you process audio data? What kind of approach you're going to take to actually making sure that the software can understand what audio data is and actually work with it confidently. Now, of course, as Dr. Fluchenko has already mentioned, there's no particular right or wrong answer to this question. There could be many approaches to it, so we're looking forward to actually seeing how you would approach this critically. And the second point is, how would you process data in multiple languages? For example, Kazakh language with Russian code switching or English code switching. Because as we know, people often tend to switch codes within their speech. And I just spent around 30 minutes talking about how to actually make corpus and how to process the text. But this all largely relies on the fact that corpus is monolingual, that it doesn't have any particular insertions, except for probably abbreviations or some other specific words, but those can be accounted for in the exceptions. However, what if you have Kazakh language with Russian insertions? What if you have Russian suffixes? What if you have Kazakh suffixes? How would you process this kind of data? Because just regular parsing in this case would hardly do. You actually need to find out how to work with this text. So we're looking forward to seeing how you're going to approach those two questions.